Heat treatment is like magic for metals. It involves heating and cooling them in a controlled way. This process changes the metal's properties, like its hardness, strength, and ductility, its ability to be stretched. Imagine trying to bend a metal spoon. A heat-treated spoon might be stronger and resist bending, while an untreated one might bend easily. Heat treatment works by altering the arrangement of atoms within the metal's structure. Think of it like rearranging Lego blocks. Different arrangements give the metal different properties. This process is crucial in many industries, from making cars to building airplanes. Heat treatment is not a one-size-fits-all process. Different metals and applications require different heat treatment methods. These methods are like recipes, each with specific steps and temperatures. In the next sections, we'll delve into some common heat treatment methods. We'll explore how they work and what makes each one unique. Imagine looking at a metal under a very powerful microscope. You would see that it is made up of tiny crystals called grains. Normalizing is a heat treatment process that focuses on these grains. In simple terms, normalizing is like giving the metal a fresh start. The metal is heated to a specific temperature and then allowed to cool slowly in the air. This process helps to create a uniform and refined grain structure throughout the metal. Think of it like organizing a messy room. Normalizing helps to arrange the furniture, the grains inside the metal, making it more organized and balanced. This results in a metal that is stronger and more predictable in its properties. Normalizing is often used as a preliminary heat treatment. It prepares the metal for further processes like machining or hardening. It's a fundamental step in ensuring the quality and reliability of many metal products. Annealing is another important heat treatment process that focuses on improving a metal's ductility. Ductility refers to a material's ability to deform under tensile stress. This is often characterized by the material's ability to be stretched into a wire. Annealing achieves this by heating the metal to a specific temperature, holding it there for a period of time, and then slowly cooling it down, often in a furnace. This process is akin to relaxing after a strenuous workout. The heat allows the metal's internal structure to relax and relieve any internal stresses. This results in a softer and more ductile material that is easier to work with. Annealing is particularly useful when working with metals that have become brittle after cold working. Processes like bending or shaping at room temperature. It allows these metals to regain their ductility, making them easier to machine or form into different shapes without breaking. Quenching is a heat treatment process that aims to increase a metal's hardness. This is achieved by rapidly cooling the metal in a quenching medium, typically oil or water, after heating it to a specific temperature. Think of it like plunging a hot iron into cold water. The rapid cooling freezes the atoms in the metal's structure in a specific arrangement, resulting in a harder material. Quenching is commonly used to harden steel, a vital material in countless applications, from tools and knives to automotive parts. The hardness achieved through quenching allows these objects to withstand wear and tear, maintaining their sharpness and functionality over time.